Okay, we're going to look at Le Chatelier's principle and the effect of concentration changes and temperature changes on a reaction. So when we mix the two of these solutions together in our test tube, we should have a red solution. So for the first part A, to investigate the effect of concentration, first of all, you're just mixing the two solutions together, and we should observe that the solution turns red. So you can draw your diagram, and here are the two solutions in the test tube, and then it goes red. The observation, or the explanation for that observation, is that when these two chemicals mix together, this substance here is formed, and the right-hand side of the equation is now favoured. So beforehand, before these were mixed, we have a yellow solution and a colourless solution alone, and when they're mixed, we have more concentration, or there's more of this being produced, obviously, because they're mixed together. So we're going to get a red solution. So the right-hand side, where the products is going to be favoured. Now to turn this. So once we change the concentration, we're going to add in HCl, hydrochloric acid, until a colour change is observed. So when you do this, the observation that you're going to make is that the solution turns yellow. So if we go back here, the yellow substance was the Fe3 plus ion, which we got from iron chloride. So when we're adding in HCl, we are feeding more so this side of the equation, the left-hand side of the equation. So we'll see that after a while the solution turns yellow. So explain that observation. The equilibrium shifts back to the left-hand side where the iron chloride is. As the chlorine ion comes in, as we know, chlorine is a halogen and it's a good oxidizer. So it oxidizes this, breaks up this chemical, and it shifts the equilibrium back to here. Because the iron is oxidized, it'll join back up again with the chlorine from the HCl and form more of this substance. So we're going to get a shift towards the left-hand side in this scenario. Then once we add in some potassium thiocyanate, again, so we're shifted to the left-hand side, but now we're going to add in more of this. So we're actually going to balance it out again. Once they're balanced, the solution will turn red again because we've basically relieved the stress on the equation and it's gone back to red again. So it'll shift back to the red side, producing more of these ions. So we'll see that red colour again. Then in B, we are investigating the effect of temperature. In this experiment, we'll investigate the effect of temperature, okay? So we have endothermic going this way, exothermic going this way. Endothermic means it takes in heat, exothermic means it releases heat. So we're going to mix together about 10 centimeters of the iron chloride and 1 drop of potassium thiocyanate. Again, we'll see it goes red, it shifts to the right-hand side because this ion is being produced. So there are your two observations there. Now on the other side, the step was to divide the solution among 3 test tubes, put 1 in hot water, 1 in cold, and leave the third at room temperature. So there were your 3 things that you wanted to do. So we're going to see how the temperature changes affects each. So in hot water, you should observe that the red turns yellow. When we add the test tube into the hot water, that's increasing a stress onto the system by making it hotter. So the system is going to react in the opposite way, which is the endothermic reaction. So just as a little typo here, this is exothermic going this way, this is endothermic. So we're going to be taking in that extra heat, and that means we're going to look at the endothermic exothermic reaction, which takes in heat. So if we're going this way, it's going to produce more of a yellow colorless solution. Now when we're in the ice bath, again, we're having a different type of stress on the system. We want to balance that by releasing heat to bring it back to the normal temperature. And so we're going to release it through the exothermic energy, this side here. So we're going to go this side instead, and it's going to look like the red solution more so it should be a darker red. And in the room temperature one, there should be no difference at all. It should just stay the normal red.